Good afternoon. It's not lost on me that I'm between you and drinks, so we'll be very concise. Anyway, welcome to the new industrial revolution. That's what we're calling it. And that's your data as the input going in, and intelligence and insights coming out is the output. And this is enabling financial services firms to make better decisions. But there is one constant change, and that constant is change, and the pace of change is accelerating. Let's use a couple of proof points. In the last 12 years, AI models have grown from millions of parameters to billions of parameters, almost 3,600x. And they're growing by 20, 30x a year. Data volumes are exploding, data varieties, data sources are exploding, and data types are exploding. And the transactions we have to process are continually going up, 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 up. And so, our first observation at NVIDIA, or our founder's observation, was that we're going to need a new type of compute. We're going to need a new way of processing, and we'll talk a little bit about that as we go through. The concept of an AI factory is this concept of being able to generate intelligence with your data. For 6 decades, data centers have been a place to store information and retrieve information and reformat it in useful ways and try to manipulate it to generate insights. But for the first time with generative AI, we are now able to generate new content from information. So we're going to talk some more about that as well. That is why KX, NVIDIA, and Dell, and others are working together. It's to create these factories, these reference architectures that you can readily deploy on your premise, in a colo, with a partner of yours, an exchange partner, or in cloud. Am I controlling this? I am. Okay. So, AI isn't new. It's been around for decades. It's been around for years. And most firms have AIs in production, but the leaders have hundreds of AIs in production. And they have plans to add hundreds more very shortly. And these are the firms that are racing ahead. So what we've observed, and we're headquartered in Santa Clara, California. Most financial brands come to visit us for an executive briefing when they're doing their Silicon Valley tour. We're a pretty popular stop. And we get a lot of feedback. But let's harken back maybe to the 90s. So, I don't know, there's maybe a few of you that are old enough to remember. I am one of you. In capital markets in the 90s, trading on fundamentals was the standard. And there were a few firms popping up, curious, innovative firms that were thinking about using math and statistical algorithms to divine correlations from data. Very different from fundamentals. Everybody in the early 90s wanted to be the next Warren Buffett, but these firms were radically moving in a different direction. And what's interesting is the algorithms they created, these algorithms were called by the industry, wait for it, black boxes. Sound familiar? And what's interesting is today, algorithmic trading is the norm. And in that period of time, transactions have exploded, the amount of data we process has exploded, the amount of the variety and sources of data have exploded, the amount of people that's employed by the industry has grown. They just do higher level thinking, and they do less lower level doing. So we've already seen this transformation. And those early algorithms were the beginning of machine learning, which you see here is represented maybe as level 1 on your journey to adopting AI. So Machine learning started coming into the business a long time ago, 30 years ago. And as firms are thinking about deploying, over the last 30 years, more innovation has happened, and we have had deep learning models evolve. And these recurrence models are they're smarter than machine learning models, but then we've had the introduction of generative AI, super powerful. Let's just think about this for a minute. A recurrence model is sort of like having an analyst working for you that can read a token at a time, a word at a time. And so his understanding of the world is at a word at a time. That's what we've been using to generate insights, to understand sentiment for the last however many years. Gen AI comes along, and now you have an army of analysts who can read the entire corpus of information instantly, make the connections, and understand exactly what is meant, and start to find patterns that are so subtle previous generations of AI couldn't detect them, and humans couldn't detect them. So this evolution, level 1, level 2, level 3, is what firms are going through today. Most firms have a very well-defined governance and model validation process. It has to be recalibrated for the new technologies, and some firms have already done that or are in the process of doing that. So the key takeaway is that as you move up that maturity curve, you're using more and more of your data to generate better decisions, more accurate decisions. As models have gotten bigger, and as we've been able to introduce more data and the compute to drive it, we've been able to do more things. And we've been able to do more things with less. We've got the classic iceberg slide at the end of the day where what the opportunities we see we're just seeing the beginning of the opportunities, and there is so much more beneath the surface, right? Think about some of the opportunities we have. I like to think of the value drivers of AI. I'm going to come over here because it's less, that light's not there. Productivity improvement, cost efficiency gains, and new revenue or profit streams. So productivity. Most of you are probably experimenting with AI to code and making your coders more efficient. But we can also use AI to generate automatically documents and start streamlining the risk management process. Many of you are probably using AI to try to lower cost in your operations. For many years, you've been using technology to seek out the best path, the smartest order route, and make sure trade execution happens at the best market price. We're doing that with AI, with generative AI as well. And then lastly, how are we generating new revenue streams? We are engaged with firms that are investing tens of millions of dollars in our platform. And they're using this to create these massive repositories of structured and unstructured data, reaching exabyte size. Amazing. I mean, when I was at Teradata in the mid-90s, early mid-90s, we didn't even know what an exabyte was. Exabyte size data sets are being mined for alpha signals. So there are some challenges. You've heard, I think probably every speaker has probably talked about the challenges. When firms come to see us, they talk about data, they talk about cost, they talk about model accuracy, they talk about all the things you probably deal with every day and have your entire careers. I'll give you a little sneak preview into our 5th annual FSI survey, which is not out yet, it's about to come out. For the first time, talent has trumped all the others as the top issue. So think about it. When you're out recruiting, this is what we hear. When firms come visit us, we hear recruits are asking us what kind of compute we have. Recruits are asking us what tools we have. Recruits are asking us, are we going to be able to publish? How many approvals does it take to get something done? So a lot of work has to be done in financial services, not just on the tech stack, but to improve moving models through approval phases, to also make sure that you can recruit and retain the best minds. Prabhu talked about this. This is probably our favorite chart at NVIDIA, so we always have to put it up in every presentation. This is our accelerated compute stack. And so the two questions we try to answer are, what is it, and why do we need it? And so let's start with what is it. Actually, let's start with our founder's observation in 1993. And by the way, fun fact, both KX and NVIDIA were founded in 1993. Second fun fact, we were founded in a Denny's. Okay, our accelerated compute stack, why do we need it? We think AI is a full stack problem. Models have gone up in size 3,600x, data has exploded, we're dealing with exabyte data size. We need a new type of compute. And Jensen saw this in '93. He knew that the architecture for 6 decades that you've all relied on, CPU servers, was running out of gas. And when he saw this, he recognized we're going to need to do something different. But what was great about Moore's Law is that if you take a step back and you get away from all the speeds and feeds, you were able to accelerate workloads every time you upgraded your server. And when you make software run faster, it makes you more money. It allows you to do things with less, more cost efficiently. And it enables you to hire more people so that you can expand your scope of business. But he saw it. Moore's Law was ending. And we were going to need something different. And that's what we've built. It's a 3-layer cake. The first layer, the base layer, is the engine of high-performance compute, the engine of AI, and the engine of computer vision. What do I mean by that? So there were 3 problems we needed to solve. The first was the backlog created by the fact that a CPU executes one instruction at a time. And so Jensen invented the GPU. We have thousands of cores. We can execute thousands of instructions in parallel. Problem solved. Second problem we had to solve was the data path between CPU, GPU, and high bandwidth memory was PCIe. It's really slow. And since we're here with KX, and they're an Irish firm, I think almost everybody, maybe Ashok's the only one who's not Irish. It's like driving on a single-lane country road in Ireland behind a horse and buggy. That's what PCIe is like to a computer. It's really slow. So we acquired a company several years ago called Mellanox, an Israeli innovator in networks. And they built, together with us, we innovated and built NVLink, NVIDIA Link. And it is the German Autobahn. It is 8 times faster than PCIe, and it makes data fly between CPU, GPU, and high bandwidth memory. Second problem solved. Third problem we had to solve was, how do you scale this? And so Mellanox to the rescue with InfiniBand. InfiniBand is the highest performance, lowest latency server-to-server interconnect on the planet, and that's what we use. So now we have AI factory at scale. So, by the way, along the way, we designed our own CPU. You heard Prabhu talk about Grace. Grace is an ARM-based CPU designed and delivered by NVIDIA. It's twice the power of an x86 CPU for the same watt. So we built a super chip, Grace Hopper, connected by NVLink, scaled through InfiniBand, and we've created an AI factory hardware platform. Now, what do you do with that? We need the second layer of the cake, which is the operating system of AI, or NVIDIA AI Enterprise. And so what we did, we had 3 problems to solve. The first problem was we certainly couldn't ask developers to go learn how to code in CUDA or in machine-level language. And so we had to abstract them from that. And so we built libraries that allow them to write their code in C++, write their code in Python, write their code in Scala, write their code in SQL, in Java, and abstract them from the platform. They're more productive, they're writing in the language they want to. The second problem we had to solve was now making that operate in an optimized way, deliver the best performance. And we actually are obsessed with this. And so we have over 450 libraries inside of NVIDIA AI Enterprise, and all they do is accelerate workloads on our platform. And every month, we deliver a new release. If you were to buy an NVIDIA GPU, by the time you've decided it's too old, say 3 years later, you will have gotten a 3 to 4x performance boost just on the software optimizations we deliver every month. The third, so optimized, solved. Third problem is you have to deliver this to enterprises, so it has to be resilient, it has to be hardened, and so we have to deliver security updates, we have to debug, we have to develop, understand, listen to the problems you have, and build new solutions for you. And so we're always on the lookout. I'll give you an example. We got a call from a very large, actually I can say it because they published it, we got a call from Bloomberg. And they were building their own foundation model. And they were having trouble getting it to converge, and they asked for help. These are some really, really smart people. And, excuse me. And so AWS and NVIDIA helped them. I think we took the training time down by orders of magnitude between the two of us. And along the way recognized, you know what, this was in February of 2023, so we need to build an inference engine for large language models. And so we did. And we call that Tier T LLM. So we want to engage with you to understand the problems you're having, and if we need to build something, we will. Best ideas come from customers. The best ideas come from customers struggling with a problem that only our platform will solve, and we want to understand that. So that's the operating system of AI. The third layer of this cake are development frameworks. And so the development frameworks that matter to financial firms, the first is NeMo. NeMo started out as a project with Microsoft that we called Megatron, way long time ago. And Megatron code is everywhere now. But NeMo we've been working on NeMo for a very long time. It is a composable, microservices-based framework that gives you the ability to curate data, to build AIs, train AIs, and inference AIs. We were the first to release guardrails. We've built a retriever RAG mechanism, which we've worked very closely with KX to implement in capital markets. So without getting into the details, NeMo is a framework for building generative AI AIs at scale. The second is Modulus. Modulus is a physics-based framework that can be used to build extreme weather AI prediction models. Very cool. The third is Morpheus, and Morpheus is a framework for cyber, to build AIs for cyber. So we have others. We have a framework for robotics. We have a framework for auto self-driving. We have frameworks for, a lot of frameworks across industry. If you come out to see us in Santa Clara, you'll get to see all of this. So this 3-layer cake lives under the hood. We don't build finished software. And this is why ecosystem is so important to us. Jensen's second observation was that AI, to thrive, needs to be available to everyone. And in order for that to happen, we would have to do something that's insanely hard. And that is decompose or deaggregate this platform, build the reference architecture, then disaggregate it and offer it to everyone a la carte. And then help them integrate it into their operation. So AWS, Azure, Google Cloud, Oracle Cloud, I have to count on my fingers, make sure I get them all. They all implement a little bit differently. They have different control planes. And so we're we're down in the engine with all of them. Same thing with all the server vendors. And Dell has taken our reference architecture and built something incredibly cool. They have built a reference architecture for an AI factory that you can put in your data center. And you can start with one building block and expand as you need to. So this is what we mean by an accelerated compute platform. It's the building block of AI factories. We're the only ones on the planet that do this. There's lots of hardware accelerators, but they're just hardware. And you own the life cycling. You own the software. You've got to go figure out what libraries you're going to use. You own that maintenance. We take care of all that for you. And this is a picture of NeMo. I'm not going to get into it, but I think the thing to realize is that you can build, when customers say to us, we're having trouble driving model accuracy up. Well, what are you doing? They're taking an API, they're training the API, or they're just using the API and they're getting a 65, 70, 80%, depending on the question, accuracy rate. But if you start taking an open source model like a Llama and you train it on your data, an open source model is like a smart, any model is like a smart university student. They're really incredible, but they don't know anything about your business. Just like a new hire. You have to train a new hire on your business. You have to train a model on your data. And so you take an open source model, you train it on your data, and you apply a guardrail to it. So you've now fine-tuned or parameter efficient tuned or done something with your data with this model. You've created a vector knowledge base with KDB AI. And you're bringing your internal knowledge into KDB AI. Now you've got guardrails, fact-checking, making sure you only connect to secure sites, ensuring that the model only talks about things you want it to, no religion and politics. And at the end of the day, you can improve model accuracy. We're seeing 90, 95% accuracy obtained using all of these capabilities in NeMo together. So I call this the better together story. This is Jensen's vision. His vision is that AI is a team sport. No one vendor and no one company can build this on their own and do it because it's moving so fast. Once upon a time, maybe you could do that, but it is moving so fast, no longer can we do that. And so you need the right partners. And the concept is you want to build and leverage complementary expertise. What's better than the guys who mastered time series databases for capital markets 30 years ago? The guys who built the as-of join. I spent 12 years at Oracle. If you ask an Oracle relational database, and I love Oracle, don't get me wrong, still have stock. If you asked it, what was the price of this equity as of this time, it would take a long time and a lot of compute. KX delivers that in a blink of an eye. And so that same DNA is built into KDB AI. And so now taking structured data and unstructured data and bringing it together so that you can create these massive data sets and start interrogating them, having conversations with them to understand where the opportunities are is real. We've built that blueprint. Talking about blueprints. So this is one of the things that we're doing. We're working with the ecosystem to make sure that you have a template that you can deploy anywhere, in your data center, in an exchange, in a colo, in cloud. If you're concerned about data, if the data is so important you don't want to put it in cloud, like for example, we'd probably never put our chip designs in cloud. It's just, if something happened, it would just be, it would be the end of us. We're using AI, while we're talking about chip designs, we're using AI inside of NVIDIA to build chips. We couldn't build chips today without it. Think about it. What it takes humans to do, it would take humans 1,000 years to run all the simulations we run in 10 minutes in the virtual world using AI. And so we're able to eliminate the things that don't work. And before we go to our supply chain with something to tape out, we know it's going to work. And because of that, we're able to deliver a new radical architecture, radically better architecture every year. Blackwell. Blackwell is now in production and delivering in Q4. In 2012, we built the first supercomputer with GPUs. I think it was called Titan. Doing this from memory. 17,500 GPUs. It took up a tennis court, consumed 10 megawatts of power, probably cost $100 million, and generated 20 petaflops of AI performance. Blackwell fits in the palm of your hand, generates 20 petaflops of AI performance, 208 billion transistors. It draws 3/4 of a kilowatt of energy, and it costs 40 grand, 30 grand, 40 grand, something like that. You have to ask Dell. So at the end of the day, in 10 years, we went from 10 megawatts to 3/4 of a kilowatt, a tennis court to the palm of your hand, and they both generate $100 million, $30,000, and they both generate 20 petaflops of AI performance. Well, a petaflop is 1,000 million floating points, right? Well, what the heck is that? It's a research assistant that can read 1,000 books and summarize them every second. And you have 20 of them with every Blackwell. What could you do with that? What could you do with that with KX, with a structured, unstructured environment complex of an exabyte size? The possibilities, if we go back to that iceberg slide, the possibilities are enormous. And the leaders who are spending tens of millions of dollars with us a year are doing this. Of course, they don't tell us what they're doing, and we can't talk about it. The cool thing is, you don't have to just use generative AI. Today, the leaders have hundreds of AIs. Tomorrow, they'll have hundreds more. In a couple of years, they'll have thousands. So you'll have a model library of thousands of AIs comprised of a mix of machine learning, deep learning, and generative AI. And what's going to dictate what you do, or what model type you use, or class, is the problem you're solving. The amount of data you want to analyze, the time horizon you have, the amount of money you're willing to allocate to it, right? Because the juice has to be worth the squeeze. So at the end of the day, starting to think about how are we going to life cycle intelligence and who are the right partners to help us do that is what we need to do. And so starting out with machine learning is perfectly fine. Building up to quant solutions based on a KX RAG workflow running empowered by NVIDIA that enables Gen AI-powered trade research, trade execution, and risk management is where we're heading. So having the right partners is super important. We have great expertise. I mentioned that we are building these AIs to help us build chips. We've built AIs to help us write software. 2/3 of our 30,000 people are software developers. Probably people don't realize that. And so our problem, our big problem, our needle-moving problem is chip design, software development, and supply chain, right? What's yours? That's where you want to start. Think big, start small. And so how could we start? We have a launch pad. One of the largest payment networks on the planet has built a huge super cluster of our platform in their data center that they're using for fraud, they're using for disputes resolution, they're using for lots of different use cases. But they're running 20 POCs on our launch pad right now. Dell has a lab. It's built. KX, NVIDIA, Dell, we've built a lab. That's available. We can run POCs together. We were talking about them in the last. So it's time. The thing you keep in mind You don't want to go too fast, but you don't want to go too slow. You've got to find the right balance for your organization, and you got to get started.